Hello and welcome to yet another lecture on Basic Electrical Engineering, paper code ESEE101. Myself, Prathita Roy, Assistant Professor of Dr. Sudhir Chandra Institute of Technology and Sports Complex, Department of Electrical Engineering. Today, my topic is Principle of Operation of Buck converter. Lesson objective. After the end of this topic, students will be able to understand the working of Buck converter. So generally, the power electronics converter are used in industrial, commercial, and domestic applications like traction, transmission, motor control, power supply equipments, inverter, fed AC system, domestic equipments. Basically, those converters are classified into four categories. They are rectifiers, DC to DC converters, inverters, AC stage controller. So, DC to DC converter circuit. A DC to DC converter or the chopper is used to obtain a variable DC output voltage from a DC or constant DC input voltage. A DC to DC converter is used to obtain a variable DC output voltage from a constant DC input voltage. The average value of the DC output voltage is varied by varying the proportion of the time during which the output gets connected to the input. The variable DC output voltage from DC to DC converter is achieved by using the combination of an inductor or capacitor along with a static switch, that is the power semiconductor devices like BJT, MOSFET, SCR, GTO. In a high frequency switching technique, in such converter circuit is called pulse width modulation technique. Choppers, that is generally DC to DC converters, are nowadays used in mainly industrial application when variable DC source is required from a constant DC source voltage. Typical application of such DC to DC converters include electric vehicles, uninterrupted power supplies, that is UPS, battery operational equipments. These are generally basic kinds of choppers, that is the buck converter, that is step down chopper, and other is the boost converter, that is step up chopper. The buck converter that produce a variable DC output voltage A buck converter that produces a variable DC output voltage that is less than or equal to constant DC input voltage, while the boost converter produces the greater or equal variable DC output voltage than the constant DC voltage. A buck boost chopper has a capability of varying the constant DC input voltage in such a way so that a variable DC output voltage is available at its output, and the magnitude of the variable DC output voltage can vary from a lower to higher value of input voltage. Now, today I am going to discuss about the principle of operation of buck converter, that is known as step down chopper. So this is the general pictorial view of a buck converter. A switch along with a resistance that is connected. This is the DC to DC buck converter circuit. So for the buck converter, we will assume that the converter internal circuit has no voltage drop during the on state. The converter that offers infinite resistance but no leakage current during off state. The converter can switch from either state instantaneously. There is no power loss in the converter circuit. Now if I go to the operation, that is the DC to DC buck converter circuit, when the switch is W1 is closed for the time, say time duration say T1, the input voltage, that is V in, that appears across the load R. When the switch is closed for the time duration say T1, the input voltage V in, that is come across the load R. Now say for the time T2, when the switch S1 is remain off or say the open, the voltage across the load will be 0. It is clear from the figure. So, what is the total time period? The total time period for one cycle, that is T, is equal to T on plus T off, that is T is the summation of T1 plus T2. So this is the voltage wavefront across the load resistance for buck converter. So this is an entire, say a one time period, that is T. T1 is the on time or the time when the switch is on, and T2 is the off time, the time when the switch is off. This is the output voltage V out across the load, and this is the time T. So it is clear from our discussion that when switch is closed for the time duration T1, the output voltage V out equal to V in. And when the switch is off for the time duration T2, the output voltage across the load is 0. So for a particular cycle, particular one cycle, that is for a time period T, this is the pattern of the output voltage that we have obtained for a DC to DC buck converter. And these cycles, and it is repeated in nature. So what is the average output voltage of from a buck converter? So average output voltage from a buck converter can be calculated. That is the summation of the total output voltage, that is integration over 0 to t, the output voltage V out of dt. This is the total output voltage divided by the time period 1 by t. So that is the V out equal to V in for the time period T1 up to T1. So the output voltage after doing the integration, the average output voltage now T1 by T into V in. So we can replace that F equal to 1 by T, that is known to us, and F generally known as the frequency of chopping. So we can replace the 1 by T by F, and the average output voltage became F T1 V in, where F is known as the frequency of chopping or chopping frequency. So output voltage, that is the average voltage V out, V O, V suffix O, that is written as, it is equal to D V in. So another term that is arrived is called the D. So D is nothing but equivalent to T1 by T or FT1, and it is known as the duty cycle. So another term that is arrived, that is called D, it is equal to T1 by T or say FT1. It is known as duty cycle D. So what is the average value of the load current? The average value of the load current is average output voltage by the load resistance R, this one. So the average output voltage, that is V0, is, we can write it, it is equal to dV in by R. So this is the formation of average load current, that is I average is equal to dV in by R, where D is the duty cycle. So now what is the RMS output voltage? So RMS means first we will do the square, followed by mean, followed by root. So if I do the square of the output voltage, that is V out square, mean means integration over 0 to T1, that is dt. T1 means dt divided by 1 by t, total time period, to the power half, that is first the square followed by the mean, then followed by the root. So T1 equal to dt, that is known to us. So we can write D equal to T1 by T. So the average output voltage, so the RMS value of the output voltage, that is V0 RMS, is now equal to root over D V in, that is the RMS value of the output voltage, that is V out RMS is equal to root over D, root over of D V in. So the converter being assumed to be lossless, that we have already assumed, the input power of the converter must be equal to the output power, as the input power can be written as V out I out dt integration over 0 to t1, that is dt, divided by 1 by t. So after the calculation, the input power became D input power, that is P suffix in, became equal to D into V in by R, that is the P suffix in. The internal resistance that is seen from the source side is equal to R in, that is R suffix in, that is the internal resistance, is equal to V in by I average. After putting the value, it will be equal to R by D. So it is observed that the duty cycle D that can be varied from 0 to 1 by varying the T1, T or F, the duty cycle, that is D, and it will be vary from 0 to 1. It is clear. This is the duty cycle that can be vary. If I vary the T1, it can go up to 1, the maximum value, or 0, the minimum value. So it will be vary from 0 to 1. The DC output voltage can also vary from 0 to V in by controlling the duty cycle. So the power handling capacity of the converter is controllable. That we can assume that we can come to a conclusion that the power handling capacity of the converter is controllable. So this is the basic operating principle of buck converter that we have already discussed. So another operation of the buck converter, that is with RL load. With the RL load, we will discuss the operation of buck converter. So this is the DC to DC converter where a L is inserted in series with R. That is called the RL load. The load that in the previous case it was only R load is there, but we are inserting a inductor L in series with the R in order to make it a RL load, that is the inductor L. So this figure that represents a DC to DC buck converted circuit where an inductor L is added in series with the load resistor R in order to eliminate the current pulsations due to switching operation. So in order to eliminate the current pulsation due to the switching operation, we are adding a inductor L in series with the resistance R. So the current will R with RL load, or we can say at on state, that is, this is the basic diagram of when the switch S1 is closed, it will make the diode reverse bias. When switch S1 is closed, it will make the diode reverse bias. So that means we all know this is the N-type, PN-type diode, where this part is the P-type and this part is the N-type. So means This is the anode and this is the cathode part of a diode. This is known to us. First of all, we have to understand that when the switch S1 is closed, why the diode D is in reverse bias. First, we have to understand this. When this is called the N part or the cathode part. If I go through the symbolic view of the diode, this straight line, this is called the N type or the cathode part, and this is the P type part or the anode part, this triangle. So this is an EN type of diode. Now, when the switch is closed means this is the positive part of the voltage and this is the ground part. So this positive part will arrive here. So at that position, it is positive and it is say in the ground potential, or we can say the negative. So if Pn is positive and P is negative, this is called the reverse bias situation of a diode, and diode will be act as an open circuit during the reverse bias situation. Again, I am repeating that if the switch is closed, this is the positive part, this is the negative or say the ground part. So here a positive will be appeared and this is the negative or ground will be appeared. Means in at positive side, N junction and P junction at negative side. When N is in positive side and P junction is in negative side, this is called the reverse bias of the diode, and the diode will be act as a open circuit. So means current will flow in that path. The current will rotate or flow through that path when the switch is on. So it is clear that when the switch S1 is closed, the diode D, that is in reverse bias, and will not, on that mean it will act as a open circuit. The input voltage is applied direct across the RL load, and the input current builds up exponentially flowing through the load. It is clear that when the switch is closed and diode is open circuited, I have already told that current will rotate through that particular part. Means the input voltage, that is V in, that is come directly across the RL load, and the input current will builds up exponentially, that is flowing through the load. At the steady state condition, it is clear that the output voltage, that is V out, will be equal to V in at the steady state condition. So we can turn on this switch, or the switch is kept on for a time t1 and then it is turned off, or we can say it is opened. For a t1 time duration, the switch is kept on and then it is opened or say that turned off. So means when the switch is turned on, this is the direction of the current flow, means entire RL load will come across the switch and the current that is built up exponentially, that is flowing through the load. So at the steady state condition, the output voltage that become equal to the input voltage, and we have kept the switch on for the t1 time. then it will be turned off. So when the switch is open, say now the switch is opened. When the switch is opened, the current through the inductor switch at its open condition. So now it is clear that the current through the inductor start decaying and the finally current becomes zero. So I am telling that the current through the inductor is decaying and finally the current becomes zero. So means there will be some path for the current to flow, or in order to decay, the current will flow through some path and the current that is will flow through that particular path. That means somehow now this diode will be in forward bias, means it will create a closed circuit. How? If I see the voltage notification, that is a plus voltage across the inductor, that means this part is plus and this part is minus. So means the P portion is positive and the N portion is negative. So that means the diode is in forward bias and it will act as a closed switch and provide the path for the current through the inductor to flow. That means the current through the inductor that will start decaying and it will finally the current flow becomes zero and current will routed through that particular path. So the inductor induces voltage forward bias the diode that I have already told. If I see the notification, there is a plus, that is minus. So means the P port part is positive with respect to the N part. There is an N-type junction. That makes the diode a forward biased one and it will act as a closed switch. So means current will start flowing through the path and the inductor current that I have told that flows through the load and the diode, creating a freewheeling action. This is called the freewheeling action of the buck converted. That is, diode is conducting during off state. This is called the freewheeling action, where the current is flowing through that path. This is called the freewheeling action of diode. The diode that provides a path for the decaying inductor current that will flow through the diode. It is also known as ID or diode current. Till the switch S1 is off, till up to that portion the switch S1 is off, the diode will provide the path for the inductor current to flow or to decay. That is called the freewheeling action of the diode. The voltage across the load resistance, it is obvious that the voltage across the load resistance is zero with subsequent decaying the inductor current to the zero value. That means voltage across the load resistance will be zero. So during this period, the switch remain off in off condition. The switch that is remain off or say the open, the energy of the inductor is transformed to the load through freewheeling action. It is clear that at that instant that the current goes to zero, the voltage across the load resistance is zero. So the energy of the inductor that is transformed to the load through the freewheeling action, and it is a properly designed buck converter is to possible to have continuity in the load current even there is a off period in each cycle of the chopping operation. When the switching frequency is high, a relatively small inductance may be sufficient to reduce the ripple of the load current and to facilitate near continuous mode of current flow through the load. The ripple, that means the ripple current, that will call the, that is the variation, that is the periodic variation of DC voltage with the power supply, which has been derived from an alternating source. The ripple that is come due to the incomplete suppression of alternating waveform after rectification. So we can say that the ripple is nothing but the wasted power and has many undesirable effects in a DC circuit. It hits the component, cause noise and distortion, and may cause digital circuit to operate improperly. So we have seen the operation of the buck converter. The basic principle of operation of buck converter. We have already discussed about the principle of operation of buck converter, or say step down chopper. Thank you.